Hello, how's it going? Last time we talked about fault tree analysis and we identified hazards that could occur on our way to work or school. And we did that with first documenting that hazardous top level event. And then we wrote sub hazards and finally ending at the lower failure mode of, for instance, here a power outage. When looking at a reactor top level event of a reactor exploding. Today we're going to talk more about the full hazards analysis that's required by OSHA in many instances in processing chemicals. And an effective way to complete a hazards analysis is defining the process, and that can include collecting all the operating procedures and applicable flow diagrams or piping and instrumentation drawings. And once you've defined that process in the scope of the analysis, you can choose a hazards analysis method. The methods that I used in the explosive, pyrotechnic, and propellant industry is fault tree coupled with a failure modes and effects analysis, or a HAZOP. And so once you've, in this case, step 3 of completing the fault tree analysis, you use deductive and inductive reasoning to flush all those hazards and failure modes out. And then you incorporate each of those failure modes into a hazards analysis table. And for each row, you have the failure mode, and you can identify the hazard description and the event consequence and the safeguards, as well as a risk ranking and any recommendations. And we talked a little bit through a table like this, where you'd fill that out for each of the failure modes, the bottom levels of your fault tree analysis. And then once you've filled that out, some of the items you can complete a quantitative risk analysis, and we'll talk about that more in the future, and also integrate other elements of PSM as outlined in the OSHA 1910-119 standard. That's just a little cartoon that says the same thing I wrote above. And the recommended hazards analysis methods I mentioned was the fault tree analysis, coupled with identifying those lower failure modes and itemizing the safeguards for each failure scenario, as well as the consequences and the risk ranking. Or you can do a HAZOP, a Hazards and Operability Study. I need to correct that spelling. And here is a little drawing, a cartoon of perhaps a reactor, and identifying the fault tree with the hazardous top level event, then sub levels and sub levels down to the final fault failure mode. And then you take those and incorporate those into the failure modes and effects analysis, where you document row by row each hazard with its consequences and safeguards and risks. When should you do this? Lots of processes have not incorporated hazards analysis at the design phase, and it makes it really difficult to incorporate engineering controls, which are much better than administrative or operational controls, as it doesn't require operators or personnel to actively do anything. They're protected through that engineering control. It's more costly and can be more complex after you've completed the design and built it, rather than completing an initial design hazards analysis and integrate those engineering controls into the design. It's much better that way, and completing hazards analysis at other steps as well in terms of startup and operation, of course. And then once the life of the process is over and decommissioning of that process or building, you would as well complete a hazards analysis to make sure people are safe in removing any contaminants or completing deconstruction. And then accident investigations, I've completed many of those, and we use the same or very similar process to evaluate contributing factors that added or caused that accident. Process safety information, that's critical. We'll talk more, and there's lots of sections in the book that review process safety information, and things like PFDs, like I mentioned previously, and the process and instrumentation diagrams, procedures, and so forth. You are required per OSHA to keep track of accidents, and those can be, of course, very helpful in completing a hazards analysis. And so for your homework, I'd like you to go through these steps. I'm not going to ask you to complete a whole lot of compiling of process information, but the homework steps include completing a fault tree analysis and then filling out the hazards analysis table for cooking or canning green beans. So here's the assignment, and I've got a procedure in terms of how to use a pressure cooker to can green beans. This is something that my mom did often. We had a small garden, and we canned a lot of beans, she did, and I always looked at the pressure cooker and wondered if it was going to explode. So you're going to go through the fault tree analysis and then itemize each failure mode in the table here to identify existing safeguards, rank those risks, and potentially give recommendations to make that process safer. God lives and loves us.